You will take your 4.2 notes on a notebook paper, and this is over explanation and log equations. Before we start on explanation and log equation, I want to show you how to change the base whenever you have a log function. For example, I have log base b of x. In order for me to change the base, this is equal to the log of x over the log of b. And note that whenever I don't write anything as a base, it means that it's base 10. Well, I can also change it as the natural log of x over the natural log of b. For example, here's an example. If I say log base 2 of 10, it is the same thing as log of 10 over log of 2. Now, let's go ahead and start solving. The first problem says 3 to the power of x plus 2 is equal to 7. Maybe before solving, I'll show you a little trick on the calculator. If you decide to graph, I ask you to graph log base 2 of x, in parentheses here. Let's try to graph log base 2 of x. In order for you to graph log base 2 of x, there are two ways of doing it on the calculator. If you have the old system, you would do, if you don't know how to put the log base on your calculator, you will change the base and say, well, it is the same thing as the log of x over the log of 2. That's one way. And let's go ahead and graph it so that you see it looks like this. Now let's go ahead and do a different way. Instead of writing log x over log 2 on the y2, which I will make it a red, or why not making a pink line, and I would now do alpha window, alpha window, number 5 is log base. So alpha window on my calculator is number 5. On yours, it might be something else, but I believe it's 5 as well. Note that it's giving me an opportunity to change the base from 10 to 2 and put an X here. I'll go ahead and graph it. The first blue one is what was there, and the pink one is covering the blue one, showing that that is the exact same thing. Let's go back to our notes now and try to solve for 3 to the power of x plus 2 equals 7. The first thing I would do is change the base. So let's go ahead and change the base here. I'll change it into log function. So this is the same thing as log base. If you remember your around the word or drop the base and switch, whichever one you know, use it. So it will be log base 3 of 7 is equal to x plus 2. Now I can solve for x by saying, well, x is equal to log base 3 of 7 minus 2. Note that 7 is the only one that is being affected by the log. Or you can put, to make it easier, put negative 2 plus log base 3 of 7. Same thing, different. From here, you will use your calculator to approximate it. But my goal is just to find the exact value right now. Let's do the same thing on number 2. Number 2 is slightly different. This time, I'll have e to the power of 3 minus 2x is equal to 4. This is an exponential form. If I decide to change it into a log form, that will be log base e of 4 is equal to 3 minus 2x. But we do not say log base e. So I will say ln of 4 is equal to 3 minus 2x. I will subtract 3 from both sides to get negative 2x is equal to negative 3 plus the natural log of 4. And I will divide both sides by negative 2. And if you divide both sides by negative 2, you end up with x is equal to negative 3 plus natural log of 4 over negative 2. Well, to eliminate that negative, I'll say it is the same thing as 3 minus natural log of 4 over 2. Now look at the next one. The next one has e to the power of 2x minus e to the power of x minus 6. first thing I would do is, it looks very familiar to me. It looks like a quadratic. So I will change this one into, say, let u be equal to e to the power of x. Well, this turns out to be u squared minus u minus 6 equal to 0. And I can factor this by saying it is u minus 3 and u plus 2 that is equal to 0. Solving this will give me u is equal to 3 or u is equal to negative 2. So at this point, I will change it back, change the base back to e, to say e to the power of x is equal to 3 or e to the power of x is equal to negative 2. Well, at this point, I can solve it. That's the natural log of 3 is equal to x. So I would say x is equal to natural log of 3 or x is equal to the natural log of negative 2. But guess what? You cannot find the natural log of a negative number. So that is not an answer. This is the only answer possible. Number 4 says 3x e to the power of x plus x squared e to the power of x equals 0. Do not forget that you have algebra skills. Use your algebra skills to first factor something out. Based on what I see, I can factor in x and I can factor in e to the power of x. So I will take x and e to the power of x out as the common factor. What will be left here will be a 3 plus an additional x here, which is equal to 0. Well, the inside of the parentheses is easier. So I would say x e to the power of x is equal to 0 or 3 plus x is equal to 0. From here, I can already tell that x is equal to negative 3. That's one solution. But from here, since it's still a product, I can break it into two pieces. So x can be equal to 0 or e to the power of x equal to 0. But guess what? E to the power of x will never be equal to 0 because it's a number that is raised to a different number. Never be equal to 0. So the only solutions are x equal to 0 or x equal negative 3. On number 5, I will use again my algebra skills. So let's first start by subtracting 4 from both sides to get 3 log of 2x is equal to 6. Divide by 3 to get log of 2x is equal to 2. Now change it into exponential form. That will give me, note that when there's nothing here, there will be a 10. So that will give me 10 squared is equal to 2x. You do that around the word or drop the base and switch, whichever one works. So I will now divide both sides by 2 to get 100 over 2 is equal to x. So x is equal to 50. Let's work on number 6. On number 6, I have double logs. I cannot work with 2 logs, so I will condense these two by saying it is the log of, because of this plus, it means it's the product. So it's log of, I can put big parenthesis and have x plus 2 plus all times x minus 1, all inside a big parenthesis is equal to 1. Now that I condensed it, I would change it into exponential by saying, once again, this is 10 when there's nothing. 10 to the power of 1 is equal to x plus 2 times x minus 1. By the way, x plus 2 times x minus 1 is x squared plus x minus 2. So I will subtract the 10 from both sides to get 0 is equal to x squared plus x minus 12. If I factor this, I get x plus 4 and x minus 3. So the two possible values are x equals 4 or x equals 3. Always check your answer. By the way, this is negative 4. So I'll go ahead and check first for negative 4. If I plug in negative 4 here, I end up with log of negative 4 plus 2. In other words, a log of a negative number. Since you cannot find the log of a negative number, it means that this answer is not possible. Let's go ahead and plug in 3. If I plug in 3 here, I get 3 plus 2, possible. 3 here, 3 minus 1, positive. So it's possible as well. So your only answer is x equals 3. How long will it take a $5,000 to double at 8.5% compounded quarterly? You first have to remember the compounded interest formula. Compounded interest formula is A equal P 1 plus R over N to the power of NT. I don't know if you remember everything about this, but let's go ahead and explain what this formula is. Starting with A. A is your amount of money that you get at the end. P being the principal. A is what you get after the interest. 1 remains 1. R is your rate and it's in decimal value. For example, for 8.5%, we will talk about 0.085. That's our R. P stands for the principal. So here our principal is this. This is the principal. Compounded quarterly. This quarterly gives you N. N is how often does it happen in a year. So in this specific case, N is equal to 4. So let's go ahead and solve this problem. The only thing we don't know is T, but we know that it doubles. The price, the amount will double. So at the end, instead of having 5,000, since it's doubling, we will end up with 10,000 should be equal to 5,000 times 1 plus the rate here is 0.085 over N here is 4 to the power of NT, meaning 4 times the time. The first thing I will do is divide by 5,000 to get 2 is equal to 1 plus 0.085 over 4 to the power of 40. Well, at this point, the only way for me to solve this is if I change it into a log function. You can use log, you can use natural log, but I will use the log because I want that base. Now, if it makes it easier, rewrite it as 1 plus 0.085 over 4 to the power of 40 is equal to 2. Now, from this, you can easily see that this is log base 1 plus 0.085 over 4 of 2 is equal to 40. So divide both sides by 4 to get your value of T. Now, if you use your calculator properly, you should get T is approximately, why don't we use it together? So on this one, I'll try to put that whole thing on my calculator. So I already got my fraction there. So on top, I have a log base. So if you have this new calculator, you go on Alpha window 5. It's putting the log base for me. Now, I know that here is 2, but the base is a big number. So I'll go ahead and mess with that base. I start by opening the parenthesis. And I'll put 1 plus. I can also put a fraction or a ratio there. And it's 1 plus 0.085 over 4. I get out of it and I close that parenthesis. And I'm dividing everything by 4. Note that I put everything on my calculator. So I'll press enter and I get 8.24 years. All right, what will happen if I started with something different? Note that I got 10,000 here because they said double. So if I started with 4,000, this would have been 8,000, but by dividing by 4,000, I will still get the 2. In other words, it doesn't matter what P is. No matter what P is, it will be the same answer. Now, let's talk about, let's say for instance, I say triple and I do not give you this. And I still say the same 8.5. You will start by saying 3P is equal to P times 1 plus R over N to the power of NT. That's in case I say that the amount triples. So you will divide by p and you will end up with 3 is equal to 1 plus r over n to the power of nt. In other words, the p went away. So it doesn't matter what the principal value is, but if you're trying to triple it, you will get to the same answer regardless of the principal value.